Hello students, this is part 3 of the chapter string manipulation. In this part, we'll be discussing about the wrapper class functions. Wrapper classes use parts and value of functions to convert primitive data into string type and vice versa. Let us look here how a string data type is converted into its primitive types. Look at the syntax. There is a variable of integer type. We write it like this: int, then the variable name equals to integer dot parseInt, and the string is given in brackets. The other method is int variable equals to integer dot value of string. Look at the example now. There is a variable n of integer type. If we write string s equals to in double quote 24, this number 24 will be considered as string and stored in a string variable s. Now if I write n equals to integer dot parseInt and in brackets I write s, what will happen? This string is converted into integer using the parseInt function and stored in an integer variable n. The same thing can be done using the value of function also using the wrapper class integer, like given here in this example. Integer dot value of s is stored in the variable n. So the above syntax is used with all other data types like float, long, double by using float.parseFloat to convert string into float, then long.parseLong using to convert string into long, and so on. Next is conversion of primitive data type to string. It is the reverse of what we have done just now. Look at this example. Int n equals to 24. String s. So we have declared an integer variable n and assigned the value 24 to it. We have declared another string variable s here. If I write s equals to integer dot toString n, that means this n variable will be converted to string and stored in the string variable s. Similarly, s equals to string dot value of n will change the number n into a string type and store it in the variable s. In the same manner, other data types like long, float and double can be converted into string. Next comes the string buffer data type. It is a data type that creates space in the memory, which is called as buffer memory, to contain the string. We have to create an object of StringBuffer class to do so, and it can be done as follows. String buffer, then the object name equals to new string buffer. This is used to allocate memory, the new operator. Now the next statement is string buffer obj equals to new string buffer computer. In the memory which is allocated, the string for the string value, we are assigning the value computer here. The third method is string buffer obj equals to new string buffer 25. So what will this do? This will allocate 25 space of memory. 25 will be the maximum number of characters which can be stored in the object obj of string buffer type. So the first one is doing what? The first one is allocating an empty space in the memory to store a string. The second statement is allocating memory for the variable obj and initializes it with string computer. The third statement allocates memory space to certain a string, to contain a string up to 25 characters. These are the three methods by which we can declare an object using string buffer data type. Now we have some string buffer functions here. The first function is the append function. This function is used to add a string at the end of another string. The string buffer function does not use an extra variable to store the resultant string. Rather, it changes the current object through which the string is called. See the example. String buffer k equals to new string buffer computer, and there is another object string buffer p equals to new string buffer applications. If I write k dot append and in brackets I write p, and then I write system.out.println k with a tab space I print p. So what will happen? It will print the value of k. K dot append will do what? In the string object, in the string buffer object k, it will append the value of p. So k will now become computer science. It has changed. It is adding the string science to it. So when we print system.out.println k, it will print computer science because the object k has been changed. And p will retain its original value, that is science. So the answer will be computer science, then a tab space, and then science. Look at the next function. The next function is setChar@. This function can be used to replace a character with another character at a specified index. For example, string buffer object s is being declared here equals to new string buffer, which is storing the value commuter. Now the next statement is s.schar@3, p. That means at index number 3, we want to change the character to capital P. Index number 3 means start from 0. Start counting in the word commuter. C is at 0 index, O is at 1 index, then M is at 2 index, and the next M is at 3 index. So the second M will be changed to P. So when we write system.out.println S, it will give the output as computer. I hope this is clear to all of you. The next function is the insert function. This function is used to insert a string into another string at a specified index. The previous function was used to replace a character, but here we are inserting a string into another string. We are not replacing, we are inserting in the middle. See here in this example, string buffer s equals to new string buffer computer fun. This is the first string which is stored in the variable s. The next variable is p, in which we are storing the value is. If I write s.insert 8, p, that means the string p will be inserted at index number 8 in the variable s. Since it is written s.insert, so it will be inserted in s. Start counting the value, the index number in the string, the first string. C is at position number 0, then O is at position number 1, M is at position number 2, P is 3, U is 4, T is 5, E is 6, R is 7, and then space is 8. So at the place where space is there, you have to print the new string is. So the output will be, if I write system.out.println s, output will be computer is fun. Clear? The next function is the delete function. This function deletes characters from a string from one index to another index. The string buffer function is used again. S is the variable equals to new string buffer computer. This is the value which is stored in s. S.delete 3, 5. Starting from index number 3 and going till index number 5, it will delete 3 characters. So system.out.println s will give the output commuter. Put will be deleted. The next function is setLength. This function is used to set the length of the buffer variable. If a string has characters more than the specified length, then the extra characters of the string are truncated. That means removed. And if it has less characters, then it stores null characters in the empty spaces. Example, string buffer p equals to new string buffer p.setLength 20. So a maximum of 20 characters can be there in the string variable p. The next function is the reverse function. This function is used to reverse the characters of a given string. For example, string buffer p equals to new string buffer computer. This is the string which is stored in the variable p. If we simply write p.reverse and print system.out.println p, it will give the output as the reverse of the original string computer. See, this function can be directly used now. Up till now you had been doing reversing of a string, isn't it? How? First you used to find the length of the string, then starting from the last index you used to start a loop for I equals to string dot length minus 1, then I is greater than equal to 0, I minus minus, then system.out.print string dot char at position number I. This was the loop which you used to use to print the reverse string. Now you can do it directly using this reverse function. Isn't it simpler? So this is the reverse function which is there in the StringBuffer class. The next function is the capacity function. It returns an integer value that represents the capacity of the StringBuffer object. By default, the StringBuffer object preserves a storage capacity of 16 characters. That means if no value is given, a maximum of 16 characters can be taken in the StringBuffer variable. First example is given here, StringBuffer b1 equals to new StringBuffer. Nothing is written in brackets, so it can take a maximum of 16 characters. The second one is StringBuffer b2 equals to new StringBuffer 50. This will take a maximum of 50 characters. So if I print system.println b1.capacity plus a space and b2.capacity, it will print 16 and 50. The next class is the StringTokenizer class. It is a string-related class used to create an object to accept a string in terms of tokens separated by delimiters. In Java, white spaces are considered to be default delimiters. Hence, a delimiter is also said to be a token separator in StringTokenizer object. Please remember that the StringTokenizer class is present in the java.util package. It is not in IO package, it is in the util package. To use this class, we have to import java.util package. Now the syntax to create the StringTokenizer object is StringTokenizer, then the object equals to new StringTokenizer and the string is given in brackets. Example, StringTokenizer, the object name is given as st equals to new StringTokenizer, computer is fun. Here the delimiter is space and st is an object having 3 tokens. Computer is the first token, is the second token, and fun is the third token. That means every word is considered as a token. If we want to change the delimiter to colon, it can be done like this. StringTokenizer st equals to new StringTokenizer. In quotes, we have to write computer. Instead of space, we'll be putting a colon there. Is, then a colon, and fun. This is how a StringTokenizer class is used. Now there are certain functions of the StringTokenizer class. Only 3 functions: count tokens, next token, and has more tokens. Count tokens returns the number of tokens delimited by white spaces in the given string. So it returns an integer value. In the above example, if we write st.countTokens, it will give 3. Understood? Next token, it returns the next token present in the StringTokenizer object. In the beginning, it returns the first token. So it returns a string type value. It will be more clear when we do programming using these functions. The third function is has more tokens. It checks whether there are more tokens present in the StringTokenizer object or not. It returns a Boolean value. So these are the 3 functions which are there in the StringTokenizer class. This is all in the chapter, children. Now we'll be doing programs related to these functions which we have discussed in these 3 videos. Okay, in the next part. But for now, please go through the chapter nicely. Read every statement, underline the main points, make notes from these videos in your fair notebooks. It will be easier for you to learn and revise when you read it again. And any problems we'll discuss in the class. Thank you. We'll continue with programming in the part 4 of the chapter.